Alright, what is up, play-by programmers? Today we're going to be doing another behavior basics video. Today's topic is going to be all about the memory array. The memory array is a really powerful tool to store lots of data in a series of lists that allows you to parse that data quickly. This is particularly useful for decision-making parts of your automations. It's really useful for mapping, and it can also be really useful for combat when it comes to trying to do target acquisition, deciding on what things to target, and different stuff like that. So getting a good handle on arrays is going to help you in the long run with the game. Wrong thing there. All right, so what we want to look at here is we want to go get into our array thing here. And we're going to start off with a nice clear array. And we're just going to talk a little bit about what an array is. So the way you access your arrays is right down here in the memory viewer. And inside of this memory viewer, you're going to see your array. Now, arrays are just a list of lists or a two-axis index. And so what that means is over here, you will have visual IDs, and I'll show you how to choose those. And then here, you will have numbered indexes. And so your data will be in a location based on an ID and a numbered index. So, for example, if this was like a mineral symbol, right, like a metal ore symbol, and you were looking for, what was it, index metal ore 3, you would start over here at the metal ore, you would go over to where the 3's at, and then you would come down from the 3, and there's your data, right? Or maybe this one's like a crystal, and you want to know what's in crystal 5. So you go over from crystal, and you go to 5, and bammo, there you are. But the index at mineral or at metal ore 5 is going to be different than the index at crystal 5. It's also possible that like metal ore won't even have an index 5, right? It'll only go as high as it goes. So this is kind of what your array is going to look like. So there's lots of cool stuff that you can do to add things to the arrays, to utilize the arrays to insert. So let's take a look at some of that. And let's just take a look at what it takes to create an array. Now you'll see right here, I've got a little program that's going to loop through things within a range, right? Units in a range. And then I'm using a filter for mineable objects only. So we're going to be creating an array full of mineable objects. And then we're going to get an output here that is our current unit. I probably could have named that something like current resource. Let's do that. Let's name this current resource. I don't really know how to spell resource, but I hope that's it. So current resource is right there. And then we're going to get the amount inside of that resource, because all this does is give us a location and a coordinate. And then we're going to set that value to the current resource so that we can see how much of that item is in there. And then we're going to go ahead and we're going to insert that value, right, the resource and its number. We're going to set that value to our index here so that we can see it. So yeah, let's take a look at how that works. So we're just going to step through here. Something else we're going to be doing, just like we looked at when we did our variables, over here in the arrays, you also have the ability to decide when your array erases itself. primarily, I almost always want to keep my memory arrays. So I normally move this down to keep a memory array until behavior is switched, but you can clear the memory array every time the behavior restarts, or you can clear the memory array every time the code is stopped and then started again. But I keep mine until the behavior is switched, which means when the behavior is no longer the selected when the behavior is no longer the selected behavior, it doesn't just mean changing the behavior. So I can build the array and then change the behavior and still maintain that array, which is super duper cool. So let's take a look. We're just going to step through this here, and we're just going to take a look. We're going to get our values to actually show up, and you'll see. So we picked up a resource here. We've picked up a metal ore resource, and then we've picked up how much is in it, and now we're going to add those values together, and then we're going to set that into the array. And when we look at it, boom, we've got our ore deposit and how much is in there. And now we go back through that loop, and we find a new ore deposit with a new value, and then we add that value in, and then we go through there, and bam, we have another bit in our array. And we can just keep doing this. I want to see if it's going to find, okay, it doesn't look like it's going to find another value or another resource. So it's just finding those metal ores, which is cool. So this means that we now have an array that has the values and the locations of some of these metal ore resources over here. So we can do a lot of cool things with that information. We can move to those locations. We can attack those locations. We can pretty much do anything we want because we now just straight up have references to these locations stored in our array. So let's take a look at some of the things that you can do with an array and what some of the words that you're going to see are going to mean. So up here, you'll see that we have the word index. And this is actually pretty misleading because we're inserting into an index. But this doesn't just mean index. This means up to index. So if you remember earlier I was talking, when you have your array, you have your ID, and then you have your numbers across the top, and together your ID and your number indexes your value, right? So you've got your ID and your number, and they index your value together. And so when it asks for an index, what it actually wants is both of these things, right? The ID, the visual ID, which I've used the mineral or the resource image here, and then the number associated with it is your index. But you'll see down here, when you go to loop memory, it only asks you for the ID because all it wants is this visual ID here, because then it's going to loop through each of the index numbers as it goes through your memory. So something that's pretty important is most of these memory nodes here, and you can find those, they're all linked together. And this is basically all the things you can do with your memory. But if you look down here, most of these, including this memory insert, all have the value index, or all have the word index next to this input value here. And that's not actually correct. The index, this is actually asking for either an ID or an index. Because if you ever put just the ID in without the index, then it does whatever the action is on the last node, or potentially on an empty node. So if you're getting, right, if you're getting a value and all you put is the index or the ID, then it'll give you the last value. If you set or insert and you only give the ID with no index, then it'll actually add a new value onto the end. If you remove with just an ID and no index, then it will remove the last value. And then if you insert, it does the same thing as set, but they have different values or different effects when you actually give them a number, right? When you give them an index. So your set and your insert do the same thing. When you only give the ID, they append onto the end of the list. But if you give them a number, the set will change the value into whatever you set it as, and insert will push all the values down. So if I use insert on mineral 2, this value right here doesn't change, just everything shuffles down one. So instead this would be 3, 4, 5, 6, 7. And then this new value would become index 2. If I use memory set, then mineral 2 just changes, and 3, 4, 5, and 6 stay exactly where they're at. And this value just disappears and gets changed into whatever your new value is. So let's take a little bit of a look at some of the things you can do here and how some of these work. So we've built our array here, and that works really well. But now we can use different things to work on that array. So for example, we can put the length. Sorry. Now this is interesting because memory length is asking for an index, but it really wants an ID because it's going to give you the length of the entire array. So I'm not really certain why it's saying index there, because I don't really see any value. And then we're going to do array length here. So when we do array length and we take a look at the values and we save, we can go in here and we can step through this. We need to add something else in here as we step through so that it actually populates this value. But boom. So we now know that the array here is 6 long. And that starts at 1. This is not like a traditional language where everything starts at 0. Pretty much everything starts at 1 in the behavior tree or the behavior UI. Yeah, so we get the length of that value is 6. Now another thing that we can do is we can look at the memory remove. So we can, like I said, we can just remove whatever the, whoops, I broke it again. We can just remove, and we'll go ahead and add this right here. Take that off. We can just remove based on no index, right? We can just give it the ID. And if we look on here, we've got 6 items. And then if we just hit the remove without actually going through, it removed the final number. And we know that because the final number was actually another one of these 1404s, right? Because it was just picking up 2 of these. It was picking up that 1712 and then 1404 and then 1712 and then 1404. So we took off the 1404 at the end there. And then if we give it an actual index, so I can get 2 of these 17s to be next to each other by taking out number 4 here. So we do index number 4 on ID resource, and we put that in, and when we save that, we'll see we're all good here. And as we step through, now when we take a look, we've got 17 and 17. So this one that used to be number 5 has become index number 4, and the old index number 4 has been removed. So we can do that. The next thing that we can do is we can get a value. Again, you can get a value without putting in an index. If you get a value, we'll go back to loop here so we can step through this. But if we get a value, we're just going to make a new here. If you're getting a value and you're not giving an index, you're always going to get the last number, right? It's always going to be the last one. So we're going to get 1712 here. And if we step through that, you're going to see that happen. But if I give it specifically index 2, we know index 2 is going to be 1404. And so now if we save that and step through, we're going to get indexed the way we want. And we're going to get that 1404 value. So this is really useful because when you're looping and you're getting your values out from this this array, right? You're getting the index, which is the ID and the number. So as you go through this loop, you always have access to the index of whatever value you're currently working with. So this was a really good array setup by the developer here. This loop specifically has some really, really good functionality because you always have access to that index, and that's really useful. So then we have, let's see, we've done remove, we've done length, we've done get. If we take a look at set, set is going to work the same way that this insert did over here. If we don't give it an index, we will add the value to the end. So we're just going to do this again so we can step through. You'll see we have 4 values. This set, I'm actually just going to set it to the number 2 here. So we're going to go ahead and step through this. And then when we look at our array again, we now have this 2 value set at the end here. But if we give it a different number, like for example, if we come over here and we set this to 3, then you'll see that when we step through that, it's actually going to straight up change the 3 value, right? So we now no longer have 2 of these 1712s right next to each other. Instead, we have 1404, 2, 1712, 5. And then if we look at insert here, and we go to the index, we already know, because we were using it up here, that the value appends to the end if we don't give an index and we just give an ID. But if we do give an index, then we can get some different stuff. So let's take a look. We have 1712 and 1404. So let's insert into the 2 here the value 4. And if we do that, what's going to happen is it's going to go 1712, and then it's going to go that value 4, and then it's going to go 1404. So instead of doing like set does, where it removes the value and replaces it, it's going to push all of these values down, and we're going to get a 6 here that's going to have this 2 in it. And so we'll just step through that real quick so we can see that in action. So we do that, and then we look back in here, and now we have 1712, 4, 1404, 2, 1712, 2. And then the last one, oh no, we already did remove. That's right. So because of the way this is all set up, loop is actually really valuable here because, hang on. Loop is actually really valuable here because it allows us to do some automated cleanup. And what I mean by that is we're getting these weird values. And so because you have this index, you could go in here and you could compare the value, right? You could loop through this ID, and then you could compare the value or the ID of the value or, whatever. You could break the value apart and compare certain things. And so if this ID, this mineral ore deposit, like type ID, wasn't here, then you could just remove these values. And so you would have access to that through the index. And I think that's really cool. And so the last and probably most important thing I want to talk about is the way the array works with units. Now these values, right, this 4 right here, this contains this value. But this value over here is a pointer, this metal ore deposit value. Now I've set a number already, so I don't think this number is necessarily going to change. But something that happens when, because this is a pointer, is that it will update if something happens to the resource. So let's take a look at that. Let's save and close this. Now we were getting all of our closest metal. We have 1712 right there. So let's move our scout over here. And we are going to shoot this metal ore. And we're going to destroy it. And because the value inside the array was a pointer, all of the information that it was pointing to is gone, right? You no longer have this reference right here, right? We were looping units in range, and we were getting the resource, and it was giving us the resource ID and its coordinate value. And then we were getting the resource number, right? The amount of resources in that location, and then setting the number before adding that entire thing to the memory. And so the part of that was just a pointer was the current resource part of that. And it was just pointing to the location in memory where that resource located. And so when it was destroyed, it's now pointing at a null value. And so when you look at it in the array, you're getting nothing. But it updates in real time. Now this is super crazy because the same thing happens if you pull a reference to an enemy unit. So if there was another faction over here, like an enemy faction, and they roamed into my area, and I picked up that they were here, and I added their reference to an array like that, then I would be able to keep track of that unit in my array. So if that unit was ever killed, I would know because it would disappear from my array. Or when that unit goes somewhere else, I could get their coordinates. I could send units directly to them. So if I wanted to destroy that unit, or if I wanted to scout where that unit went, right? Maybe it goes back to base, and so I follow it. I can keep track of lots of enemy units, and so I can know if I've got 50 enemy units in an array, and then 20 of them suddenly vanish, then that means that there's a big battle going on, right? And maybe I can figure out the coordinates of that battle based on the enemy units that are going down, even if they move into an area that I can't see, even if they move into an area that I have never discovered, I still know where they are, and I can still move to them and use that information, because this is a pointer that is saying, hey, this is the information. So whenever that value is sort of read, it just reads whatever is currently available in that place in memory. So that's really, really important. So arrays are super interesting. They're really, really powerful for understanding the state of the world and what's going on right now, and just looping through those arrays and making sure that things haven't changed. That units haven't been dying and stuff like that. And if they have been dying, right, if resource nodes have been getting consumed or whatever, then and you know that the state of game is changing, and your automation can start to make decisions based on that changing state. So arrays are extremely powerful for mapping, something you really do want to do if you're going to get involved in automation in this game. So I hope you all really enjoyed the video on arrays. I hope you got some help or some use out of it. If you did, don't forget to hit that like and subscribe button. Tomorrow, well, maybe not tomorrow, on the next video, we're going to be talking about faction registers and how to use faction registers, which are really, really powerful ways to communicate between your different units. So we're going to talk about that. And then after that, we're actually going to go take a look at blueprints, because I found out just the other day that even some of the players who are pretty knowledgeable about the game don't understand how to use these blueprint parameters. So we're going to take a look at blueprints, and we're going to have a little video on that once we get all done with all of our registers and variable stuff. So we're going to do faction registers, then we're going to do blueprints, then we're going to maybe get on into some practical application stuff. So yeah, I want to thank you all for coming out. I hope everybody has a great day, and I will see you all on the next one.